all. This is Dr. Mobeen Sayed from drbean.com. Welcome to one more show. I hope you had a great weekend. So today I wanted to discuss ivermectin in the context of SARS-CoV-2 and COVID-19 once more. We have done this talk a few times before. Today's discussion adds a couple of more mechanism of actions that are recently being brought to the attention. So let's start. So here, this is drbean.com. I have done one more thing, if you like. I've created this, you can see my screen, correct? I've created a forum on our drbean.com where you can discuss the topics like ivermectin more easily. The thing is this, today I try to follow you on YouTube or the Twitter or other places to see some folks send me emails. Some folks send me email at questions@drbean.com. So for me to wrap my head around all of them and to reach all of those areas and respond becomes a little tedious. And many times then I drop the ball and not able to attend these various forums. So I thought it may be useful to bring that discussion area together here. This is by no means a project to get your email addresses. You can't, or I thought it was important that somebody who is registered free on the site, only they are able to participate in the discussion, so that those folks who, for example, on YouTube uh, like to curse a lot or just blame people or just insult others, I think those can stay out because we would have the emails and we'll have a little bit more closer interaction with folks. So maybe they would find that discouraging to just come and yell and and do those kind of things, although it is everybody's right to do what they want. So here, not exactly everything they want, but within the legal and moral compasses. So anyways, I have the link to this forum in the discussion. You can actually start a new forum as well by giving your own title and asking your own question, and then we can all jump in and have our discussion. So this is one. Secondly, for today's discussion, it is also interesting to look at FLCCC's site. Many of the folks keep asking that, hey, what should be the dosage and what are the various questions they have. So there are lots of decent answers that are on the site. I saw that many of the answers were in line with the kind of discussions I have been doing, so that is a good news. So this is the site, I have the link there as well. This is Dr. Paul Marek's site. Then this is the first study that had brought ivermectin to the discussion, and this is that study where Kelly and co from Australia had demonstrated that ivermectin can help reduce the viral load. This is where the whole world started around the ivermectin. Then here is another study, older one, but a possible function of ivermectin. We'll discuss that again today. Then here is another possible function of ivermectin. This is another possible function that we will discuss today. And this is the one that I really want to, this is a new thing that we'll discuss, and this is a new thing as well, new concept. And finally, I believe this is new as well. So we have a bunch of new things, new concepts that we will discuss. So if you're ready, let's go. So you may remember this screen from our previous discussions. I always chuckle when I look at the ivermectin man, but he is a very, very helpful, what is that, Superman, right? So ivermectin man. So he's the hero that we need, and he is the hero that is present only if we can actually give it some respect and use it. So in terms of the mechanism of actions, this I think I have so much drawing here on this one that this always is slow to scroll, but anyways, here is the anti-worm effect, and we know that ivermectin man over here, if you see, it connects with the glutamate receptors on the worm, not on us, and then it can connect to our GABA receptors as well in our brain, and that is why it can cause brain damage, but very minor effect in healthy people with the correct with the intact and healthy blood-brain barrier. But for the worms, this uh, drug has an effect, and that is that it binds with the chloride channels of the worm's muscles and nerves and opens them. That causes the chloride to go into the cell of the worm, and that causes the cell to become hyperpolarized, we say, become more negative. And when a cell is more negative, then it is difficult for it to function. So if it is a muscle cell, it would not function, and the worm would not be able to breathe or function correctly and die. Similarly, if it is a nerve tissue cell, then of course the nervous system of the worm is going to be damaged and they are going to die. So this is the anti-worm effect. We've talked about it, so I'm not putting too much time in it. Then the second effect, sort of antiviral, and we have had this discussion that is it really antiviral, that is, does it kill the viruses, or is it virustatic, that is, it kind of reduce the effect of the virus. So most of the function here of ivermectin is that it reduces the virus's effect. It doesn't directly kill the virus. So it is not virucidal, it is virustatic. So here we have seen this before as well, that here is the virus. If you start from this area where I'm highlighting, here is the virus. What virus does is, virus has its own proteins that are its messages or messengers, and it loads them up on importin alpha and beta, which are our proteins. And then, so in here, this donkey is the importin alpha and beta. So then the viral cargo sits on our importins and goes into the nucleus. Inside the nucleus, the importins, alpha and beta, are broken away, they go back outside, and then the viral cargo stays inside the nucleus, where this cargo is going to tell various genes not to protect the cell and not to release the interferons. And the result is that when the interferons are not released, then the nearby cells are not made aware that there is a virus somewhere and there is an issue, and so they would just not care, and they will become unsuspecting victims of the virus. When ivermectin is present, then what happens is, and I think that you have seen these pictures before in one of my discussions, it's just that now discussion has a couple of more mechanisms. So here, if you see here, this is the ivermectin. Ivermectin is sitting here on that donkey, on importin alpha and beta, that were going to be used by the virus to send its cargo inside the nucleus. So virus is now sitting outside and crying because it cannot send the messages to the nucleus, to the brain of the cell, to say, please don't take care of yourself and please don't tell others that I'm here. So the result is that the nucleus will work correctly and make interferons that would go out, and that would tell the neighboring cells that, hey guys, we have an enemy here and it is already in me and you should be ready. And so if you see there, all those little cute cells are now ready and they're going to take care of the virus when the virus arrives. So this is a defeat of the viral behavior. And again, this is, if you see here, ivermectin is not killing the virus, it is just neutralizing the effect of the virus. Okay, continuing on. Again, because we have done these discussions before, I don't want to take too much time. Then this is the anti-inflammatory behavior, where, and this is why some of the long haulers, when they use ivermectin, they feel better. They feel better for two reasons. Number one, their system, if there is virus hidden somewhere or viral debris hidden somewhere, the cells can still not be too much bothered and not release or continue to release interferon and function correctly and not die and not cause apoptosis, and that helps them. And secondly, the anti-inflammatory effect of ivermectin is also useful. So if you see here, again starting from the top left here, So this is a toll-like receptor. Toll-like receptors are receptors on various immune system cells that would help them locate the pathogens and bind with them, in this case SARS-CoV-2, when these receptors are activated. Meaning when a cell, immune cell, uh, finds a virus or a bacteria, eventually in that immune cell, there is production of nuclear factor kappa B, and we've been talking about this in terms of vitamin D as well for a long time. And then there are cytokines that are produced. Those cytokines will then cause inflammation. And ivermectin can stop this mechanism as well. So if we see here, it is totally different from the virus's behavior, but the benefit here, sorry, I should have gone this way. So the benefit here is that when the virus is present, SARS-CoV-2 or other viruses, and see here, this is the ivermectin man. When the virus is present and the toll-like receptors have become activated, they have seen the virus, they have alerted the cell, and the cell is supposed to now start creating cytokines and go mad, then the ivermectin is sitting there blocking the nuclear factor kappa B's function and reducing the production of cytokines that reduces the inflammation. So this is another calming down effect on the immune system. Continuing on, so this is the new function now that I'll show you. Here, if you see, I wish my computer was a little faster. So if you see here, if I zoom in, this is the ivermectin. And ivermectin can bind between the ACE2 that is on our cells and the spike protein of the virus. On one end, it can bind with the spike protein. On the other end, it can bind with the ACE2 and then get sandwiched between these two structures. We know that virus here, the SARS-CoV-2, will love to have its spike protein bind with ACE2 so that it can then enter the cell. But what if there is a monkey wrench in the middle? What if there is a thing, if there is a molecule between these two structures, then they will not bind correctly and the virus cannot get into the cell correctly. So this is a new mechanism, and let me show you the study on this one. So here, this mechanism is observed with computer. So it is an in silico study. So we have in vivo studies that are in our body, then in vitro studies that are in labs, and in silico studies, silicon computer chips, right? So in silico studies inside the computers. So here what they have done is they've taken ivermectin and they molecule, and they took the ACE2 and the spike protein molecules, and with computer they try to assess the docking capability of these things, and they found out, if you see here, this is the ivermectin, and here if I can enlarge this a little bit, I hope I'm not infringing on their copyright, so I'll close it very fast. This area is the spike protein. This area is the ACE2, and between them is sitting ivermectin and disrupting their binding. So here is a close-up shot of that ivermectin is stuck between the two things, and the result of that is that these two things cannot bind correctly. And that is another mechanism by which ivermectin will disrupt the function of entry of the SARS-CoV-2 inside the cell. Continuing on, and again, those folks who say that how come an anti-worm drug works against the virus. So this is how it works against the virus. Again, it is not killing the virus, it is just preventing the virus from getting its way. Now, continuing on, next big function, which is also new for us, is the my sincere apology for my computer. So here, we have done this discussion in the past as well. Start from the top left of this diagram. Imagine the replication cycle of the SARS-CoV-2. That is the division, how it increases in numbers. Division is not the right term to use for viruses. It is replication or assembly. So look at this. Here is a virus. The SARS-CoV-2 virus, first of all, it needs the TMPRSS2. We know that. It is a protease. Please keep this in your mind because I'm going to use that here. It is a protease. And that is why the bromhexane or chemostat mesylate or other such things are protease inhibitors. That is why they work, because this is a protease. And we're going to see some more proteases in a second. Now the virus has bound. Then when the virus binds with our cell membrane and ACE2, it eventually sends the RNA of the virus in our cytoplasm, and that is here. This RNA is called positive. It is a positive sense RNA. That means it is an RNA that can directly enter a ribosome. It is structured in a way, the 5' end and the 3' end, the ends of the RNA are created in such a way that they can directly be inserted into ribosome without any manipulation of them, and they can start getting translated. Translated means a piece of RNA getting into a ribosome, which is a chef, and now that chef is going to read that RNA or the recipe and cook proteins. So this is a positive sense RNA of the virus. It enters or binds with the ribosome. Ribosome in turn makes proteins. There are a couple of important proteins that it makes. One is this big polyprotein. And I have been giving this example for about 8 months now, that this big polyproteins is like a big cutout sheet for children's toys. So there is a big sheet and there are small cutout of the toys, and children can just press them out and they can get little soldiers or animals and they play with them. It is the same thing. This is the virus has a one big protein that is formed, and that one big protein is called polyprotein, because poly means many, and inside there are many tiny proteins. Proteins need to be brought out and to be cut out of it. So to cut them out, we need proteases. Protease means something that can cut a protein. And remember, out here is a protein as well, which we need to inhibit. Then here are some proteases that are needed that are going to cut this polyprotein and make small pieces of them, which will be functional. And then it also makes this ribosome, will also make RDRP, RNA dependent RNA polymerase. Polymerase means something that can that can create polymers. That means it can make some things. And RNA dependent means it can read an RNA and it can look at the recipe there, and then it can make copies of that RNA. So this is a very important enzyme. From this enzyme, you might remember zinc disrupts this enzyme. And for zinc, we need hydroxychloroquine to bring the zinc in so that zinc can come in and disrupt the RD